back and forth, whether it be linear or nonlinear equations. There's a couple little bit of rules that we'll have to follow. Most of the rules that you have, you'll be able to see the rules themselves via your calculator. So you don't have to worry about trying to plot some stuff by hand here. So here's what we've got. All I want you to do real quick here is look at this table. If I have two relations, x to y, and then the inverse relation, what changed? You flip the x and the y. Thank you. For those of us that are colorblind, though, what changed? All we did was just flip the x and the y. So here's what happens. In order to work with an inverse, in order to solve and work with inverse relationships, or an inverse function, all we're doing is... Oh, you don't have to... It doesn't matter about the color part here. All I'm saying is that, can you see that the numbers flipped? One went to the x, one went to the y? No, because then you guys are going to fall asleep and you'll have to pay attention to your PBIS lesson.
No! I'm trying to say
I'm not worrying about you writing it down here, though.
But it doesn't matter, even the black on, when you write,
Uh-huh.
you can't see it because it's all it glares.
Okay. I can't help that. I'd like to have the lights on, though. All right. Anyway, all that's happening here within an inverse is that your x's and your y's flip. They change. So what we do here to find an inverse relation, and I'm going to show you the example here via a linear function to start with, is something very, very simple. If you start with your regular, something that's like in slope-intercept form, y equals, mx plus b. In this case, I have y equals 2x minus 4. If I start with that and I want to find the inverse of that, all you do is flip-flop the x and the y. And resolve it for y. And there's your inverse. Those two guys are inverses of one another. What happens here is that to show that something is an inverse of something else, basically we use some of that composite stuff we were using yesterday. Remember we were doing f of g of x and g of f of x? Remember how we were taking the functions, put them in for one another? What happens with an inverse relationship is that within an inverse relationship, let's say I want to move this over just a little bit. I want to show that these two guys are inverses. If I call this f of x, and I call this g of x, instead of just saying y equals for right now. If I take f of g of x, which is, again, taking this equation here, x plus 2, or x over 2 plus 2, substitute in for that x. When I simplify that, I get, 2x over 2 plus 4 minus 4. What do you get when you simplify all that out? X. Good. And if I go the other direction, g of f of x. If I take the f of x equation, the 2x minus 4, and I substitute in to the g of x equation, when I simplify that, I get x minus 2 plus 2, which is x. What happens here is that functions are inverses of one another if you do the composite of them and your answer is always x. So really all we're doing today is taking one function, taking one of these guys, y equals x squared plus 6, changing the x and the y, and resolving it. And that's how you find the inverses. It's a relatively straightforward setup. To verify that it worked, you would do that composite stuff like that again. And we'll do some more examples with nonlinear stuff here in a second. Not too scary? This is kind of why I said that we'll put this section in today, because it'll only take a couple minutes to go over the homework tomorrow prior to the quiz. So let's look at a different one. I'm not going to do any verification or anything quite yet. I'm just going to say I want to find the inverse of this function. This is a linear function again. I have y equals negative 2/3 x plus 6, and I want to find the inverse. So in order to start finding the inverse, you flip-flop the x and the y, so it becomes x equals negative 2/3 y plus 6, and then what do you do? Yeah, solve for y. So subtract the 6. And then how do you undo multiplying by a fraction? By the reciprocal, good. So you multiply both sides by the reciprocal, which is negative 3 over 2. So you get negative 3 halves x plus, what is that, 9. And there's your inverse. All I do is just redistribute it out. And that's it. Do you think any of this is going to change when we get to nonlinear stuff? Yes, sir?
Wouldn't the reciprocal be 3 halves?
That's opposite reciprocal. That's when if you're trying to find perpendicular.
Oh.
We're just doing inverse. We're just doing I know, and that'll happen. Everybody, I bet you everybody in every other class today is going to ask that same question. Wait, shouldn't it be? Because you guys are ingrained when you do a flip like that, when something's linear, you're thinking of that. But yeah, now in this case, we're just worrying about writing out an inverse. We're not looking at perpendicular. Okay? So what changes then when we get into stuff that's nonlinear? Oh, here's that. Sorry, I forgot I had the inverse to verify. Again, in order to verify that these guys are inverses, what we're doing is we flip-flop them around. The notation that they show for inverse is the -1 power. That's the notation that they show for inverse. There is a -1 button on your calculator. Remember how we used that with matrices? Remember how we inverse the matrix by using that button? It means the same idea. That -1 power means an inverse. So again, in order to verify that something was in fact an inverse, if I wanted to verify that 2x minus 4 and 1/2 x plus 2 are inverses of one another, we would do what we did a second ago to show that it worked. I take the given inverse of 1/2 x plus 2, I substitute that into the x of the original equation, and with any luck, I get x plus 4 minus 4, I get x for an answer.
So we're going to have to find x, or we're going to have to do the thing we did before, and then the second part of the question is find
Sometimes it'll say find the inverse and then verify. Or sometimes it'll give you the function and the inverse, and it'll say verify that.
When it's just verify, you just do the thing that we did in the last one.
Yeah.
So the verifying.
This is verifying right here.
So just plug it in, and then if it's X, then
Yeah.
it's
But you have to go both ways. Do it both times. So here's f of the inverse, and here's the inverse of f. So you have to go the other direction too. So you do 2x minus 4 times 1/2 plus 2. So I'm using both equations. Half of 2 is x, half of 4 is -2. Add them together, you get x. Yes, ma'am?
Would it ever be that one of them would actually never do?
Correct. And that will happen from time to time, and that's showing that they're not. And what's why I was asking here, guys, is sometimes they'll give you a set of functions, a function and its inverse, and it'll say verify that they are inverses. If it doesn't work out to be that they're both equal to x, then what do you say? They're not inverses. Okay? That's how this is going to work. Okay, that's all it is. And you're right, sometimes one of them might work out, but then go the other direction, it might not. So you just double check it. The algebra here really isn't gonna be all that scary. It really won't be. Yeah, exactly. And then here's where the weird stuff will happen. I want to verify that these two guys are inverses. This is the wording that it'll say. Verify that f and g are inverses of one another. In this case, I have f of x is 8x cubed, and g of x is x to the 1/3 over 2. So, to verify that they're inverses of one another, you have to take f of g of x. So I take my g of x equation, x to the 1/3 over 2, substitute in for x in the f equation. Bless you. Now I have a fraction raised to an exponent, which means I have to distribute that exponent to both the numerator and denominator. In the numerator, you'll notice that we have it going power to power. So what do you have to do when you have power to power? Multiply. What's 1/3 times 1/2? 1. And what's I say 1/3 times 1/2? I mean 1/3 cubed, excuse me. And what's 2 cubed? 8. What's 8 over 8?
1.
And there's your x. Go the other direction. I'm going to go the other direction. I start by writing down my f of x equation, 8x cubed. I surround that with the g of x equation. So that goes to the 1/3 power, and I divide it by 2. Let me move that up for you. Now in this case, the only thing that has the 1/3 power is the numerator. Again, 1/3 power means cube root. What's the cube root of 8? 2. 3 to the 1/3 is, yeah. Are they inverses? That's all it is. Okay, that's all it is. It's substituting in one for the other. Yes, sir.
Now, are most of these problems going to just like be based on finding if they, or like verifying if they are inverses, or are there going to be some that aren't like inverses?
Yeah, I'm getting to that. It'll look like this. Find the inverse of a power function. Again, this is a nonlinear function. The only thing that changes here, why I left that note up there, is notice what they tacked onto the end there. X has to be greater than or equal to 0. We should all know what the graph of x squared looks like. What does it look like? It's a parabola. You guys all agree? It's up like a cup and it's a parabola. What happens when you have an x squared function? There's a little something called a horizontal line test. You all right? Exactly. In order for something to be, in order for an inverse of a function to exist, think about when you guys had vertical line tests. Remember that? In order for something to be a function, it had to be only a vertical line can touch it one place all the way around. When you inverse functions, it winds up spinning them around. If I inverse x squared, I do not pass the horizontal or the vertical line test anymore, do I? So then it would not be a function. So what happens here is that they say only for values of x that are positive. So you're getting rid of half of your parabola. When you spin that around then, does it pass the vertical line test? So would the inverse of that be there? Would it occur? So what you're doing here is that they put this little caveat about not worrying about it not passing a horizontal line test. If that wasn't there, you would check it with your graphing calculator, if the horizontal line would go through the function more than one place, the function doesn't have an inverse. If it is there, where this x is greater than or equal to 0 is on the graph, then you have to assume that you're only looking at 1/2 of a parabola. Does that make sense? It's a little bit out there. And as we go through a couple of the examples that I have for you guys, I'll show you how you would check it in your calculator real quick and go through it. Yes, sir?
But then wouldn't some graphs not work out? Because let's say that this is the y-axis,
Mm-hmm.
and it comes down through here, and then it still has this like tail here. So then if you flipped it,
Like that?
no. Like,
Okay, so this is the graph, and it came down through here.
Okay.
And then this was erased. Then if you still flipped it, this would cross, and then it'd be.
Okay, I see what you're
one
saying.
to one.
Yes, and then that's where things that's where things will get kind of muddy. If there is like a tail on here where it's like a fully shifted over parabola, and I know where you're getting at. And that's what's good about when you pay attention where it's greater or equal to 0. So when you're looking at it on a graph, does it pass that horizontal line test if it's
Alright.
there? So you're right, since there is more of the parabola to the right of the y-axis there, that inverse would not exist because even with this value here, this value would have to be at the vertex.
okay.
Does that make sense?
Yeah.
That's a great question. That make sense, guys? That's a really good question. All right. Anyway, back to the finding an inverse of f of x where it's x equal or x squared. And we know that it's going to be for all values greater than or equal to 0. So I know that this inverse is going to exist because it's saying that it's all for the positive values. Again, the only thing you have to do in order to find the inverse here, excuse me, what is f of x also synonymous with? Flip-flop them. And then what do? Square root it. Now, do I have to worry about my plus minus here? No, and why is that? Exactly. And there's your inverse. Okay? If it was x cubed, would I need to worry about the x greater than or equal to 0 here? It doesn't. We don't need to worry about that. Because what'll happen with odd functions, a lot of times, like they have that wavy line to them. It's the even ones that wind up with a lot of the parabola style to it. Okay? But one quick way to verify is to put that y, in your y equals button on your calculator, and just type in x cubed, and just quickly look to see if there's a horizontal line. I know that the graph of the x cubed looks like it's coming up, and it might cross through here. It might touch it more than one spot at the origin, but it really does not. Okay. So if you had to find the inverse of this guy, again, y equals, so it's x equals y cubed. So it's just the cube root of x is the inverse. Yes, sir.
So on a test, if you gave us one that did cross over twice, then we need to say that this there's no inverse.
Yeah, you would say no inverse. If it doesn't pass the horizontal line test on your graph right from the original function, you just can't do it. That's too easy. I wouldn't do one like that. Or would I? So here's where we have that little bit of a shift thing. And like I said, we just talked about how to check that in your calculator. If I have f of x is 1/2 x cubed minus 2, I don't want to find the inverse. I use my calculator real fast just to get a rough sketch of what that looks like. And I'm going to check about that horizontal line test, what we've been talking about. So when you look at 1/2 x cubed minus 2, let's see, it's shifted left 2, and it's a little bit, let's see, would it be skinnier of a up and down, I believe. I'm just guessing. It looks like this, right?
Yeah, just have the long. Where it crosses over is in one's so low to do.
God, I don't know where it is.
My place is so far away.
You crushed my dreams.
Oh, it's right. It's the K value. Duh. I think I would know that. Does that pass the horizontal line test?
Yes.
Yeah, it does. Yes, ma'am.
If it's an odd exponent, don't we already know what the past
So flip-flop your x's and y's. X equals 1/2 y cubed minus 2. It's out of the way. What do you do first? Yes, sir.
Oh, I just had a question. Actually, I forgot my question.
Do you agree that we add 2?
Yes. And then you multiply by 2.
Then we multiply everything by 2? Are we okay with that by skipping that show of a couple of those steps? And there's your inverse. You guys would be pleasantly surprised that the algebra and this stuff really isn't that bad. Yeah, you got a lot more stuff to worry about than this stuff should be easy for you at least. Questions? You want to do a couple more?
Yes.
All right, find the inverse of this one. I hear people going, isn't that not? But it's only picking 1/2 of the graph though, isn't it? So is it okay if it's just picking 1/2 of the graph?
Yes.
It's going to be okay. It doesn't matter that it's looking at the negative side. It's all right. It's okay. Because it's looking at what? Just the left side, which is, it's looking at that part there, right? So if you rotate it around, does it pass? It'll pass the horizontal line test. So you can still do that. It just winds up with a kind of an ugly looking thing.
So what's the horizontal line?
Horizontal line test. Originally, if you look at this whole graph, it looks kind of like this, right?
Yeah.
If I drew a horizontal line through it, it hits both lines, right? That means the inverse of this function does not exist. But since it says that for just part of the function we're looking at, if I draw the horizontal line through it, it only touches it at one spot, which means that the inverse of this does exist. So we're able to say that, well, x will equal 2 minus 2y squared, and flip-flop everything around. Easy thing here to do right off the bat is go 2y squared is negative, I can say just 2 minus x, divide it by 2, and take the square root. Is that okay? Yes, sir.
Is there something significant that we're going to do with these?
You use this a lot more next year. Use this a lot more next year. It's just, I want you guys to get the idea of the inverse is nothing more than flip-flopping x's and y's and resolving. Yes, sir.
Quick question, couldn't you write down negative 1/2 x
plus y.
Yeah, yeah, it's the same thing. I just move stuff around. I always, whenever I'm trying to solve for a variable, I usually solve for my variables when they're positive. That's just my own style. What you did is fine. It means the same thing. That's all. Okay? It means the same thing. Give you guys a couple of these to try for tomorrow. I'm giving you some odd numbers so that way you can verify to make sure you did get them right. I don't think you're going to have too much trouble with this. Just like Mr. West was just saying about couldn't you have written it differently, you might find that tomorrow in the homework when you're checking your answers. They might have written it a different way. If you're like me and you deal with positive variables, you might get a little bit different variation. So you might just have to look at it and say, hey, can it be rewritten? Okay? Does that make sense? Tomorrow the quiz should not take more than 20, 25 minutes tops. It's not very bad. No, seriously, it should. It's short, very short. Yeah, very short. What I will plan on doing with the quiz tomorrow is that when we come into class, we'll take 5-6 minutes to go over a couple of these questions, and if there's anything left over, and then we'll go with the quiz. That way, I'll give you guys I'll give you guys a minimum of 30 minutes to take the quiz, which should be plenty of time. You shouldn't. It is written for you to be done with it in less than 20 minutes.
So if we
You're going to be in Florida. Oh, no, you won't be yet. Okay.